Welcome to Carnegie Mellon. Welcome to the exploratory technical workshop on safety and control for AI. I'm Bill Scherlis. I'm a professor of computer science. And this is the first day of a two-day affair. This is the exploratory technical workshop that Carnegie Mellon is sponsoring. Tomorrow we have a public event also framed as a workshop, which is co-sponsored by the White House Office of Science and Technology Policy and Carnegie Mellon here in the same room. It starts at 9 a.m., breakfast at 8. And to keep you busy, we're also offering a reception tonight that I think you know about in your registration packet that starts at 6 p.m. But without further ado, I'd like to introduce Ed Felten from the OSTP, who will say something about this series of workshops and its context.
Thanks. First, I want to thank Bill and everyone here at CMU who has really made this series of events possible. We're grateful to CMU for co-sponsoring the event tomorrow and for putting on the event today. The event tomorrow is part of a 4-workshop series that we are running, each one co-sponsored with a different private sector organization. But all of them around different aspects of artificial intelligence and machine learning. On May 24th in Seattle, we talked about AI law and governance at the University of Washington. On June 7th in Washington, D.C., we talked about AI applications for social good. That was co-sponsored with AAAI and the Computing Community Consortium. The event tomorrow, of course, with CMU on safety and control. And then finally, we'll wrap up on July 7th in New York with a workshop on social and economic implications of AI. When we decided to launch a policy initiative on artificial intelligence, we wanted to make sure that we covered all of the important aspects of the issue. We tried to break this down, but in conversation after conversation, we kept coming back to the issue of safety and control. How would we know that these things were doing what we thought they would do or what they were supposed to do? How would we know that extremely complex technologies would behave within the bounds that we want to set for them? And having a background as a computer scientist, and particularly in the area of computer security, this was something close to my heart because I've spent decades now of my career before going into government studying all the ways in which computers either could go wrong or could be induced to go wrong. I also know, having written a fair amount of code in my day, how difficult it is to make anything work the way it's supposed to work. And so this issue of how to make these systems safe, how to control them is, I think, the grand challenges. And I think it's one of the factors that is most going to limit the practical deployment and success of AI. And so I'm very happy to have such a great audience here to talk about it. I'm thrilled with the speakers that we have lined up for today and tomorrow. And I'm just very eager to participate in this. I'm happy to be back among my people. As you can see, I'm dressed so casually. And with that, I'll pass it back to Bill so we can get started.
All right, so we have a purpose today and tomorrow. And the purpose is really to catalyze this conversation in the community about these issues of AI safety and control. And there are a lot of questions. What does it mean to be safe? We use this word safety as if it actually has a meaning. But we have to decide what meanings, many meanings, in fact, we want to impute to that word. And if we can make progress, then what's the research agenda that we can identify? What might the future engineering practice for safe AI actually look like? And how can we kind of achieve goals with respect to some notion of safety without compromising too much on the capability of systems and their functionality? More optimistically, maybe, and sometimes we see this in the world of software, maybe we can actually use the safety conversation to kind of improve the productivity of our engineering practice overall, especially when you consider the full span from conceptualization, design, development, evaluation, evolution, reevaluation, and so on. So that's a bit of optimism, and I'll come back to that in a moment. And so there's a question which is really, does safety need, in fact, to come at a cost? We kind of imagine this trade-off curve in our minds, but maybe that's not a law of nature. And so we're going to hear some interesting results and ideas in these talks. We have a fantastic array of speakers. I think we're really, really fortunate in this regard. But as you listen to the speakers, think about these questions, and if you're so motivated, please submit a white paper through our portal. We've got the Easy Chair portal open. We're going to be taking white paper acceptance through the weekend, okay, into July, that is. Okay, and our plan is to produce a summary from these workshops. We will feed this over to Ed and his colleagues at OSTP, and I understand that their plan in the fall is to produce a report which digests the conversations of this workshop and the other three, and various other inputs to try to formulate a position on these issues. So before going forward, I just want to say a little bit about tomorrow's agenda, because today's agenda is, if you'll forgive me, it's kind of a transpose of tomorrow's agenda. You'll see what I mean in a minute. So the first session is starting with Manuela. Now, Manuela's not actually here, but she was gracious enough to allow us to create a video. It's a pretty cool video, so we'll see her by video tomorrow. And then we'll have some other talks. It's really about gaining some perspective and framing the problem. And here's the kind of questions that would come up. So what is the mission context? What are the operational contexts in which we're going to be actually deploying? What are these systems going to be doing in the world? Related to this is, how do we actually manifest AI capabilities? I mean, everybody's focused on SML, statistical machine learning, but there's old-fashioned stuff like planning and search and language processing. There's a whole gamut of features, and if you talk to people who build systems, they're employing a sort of hybridization of all these things. And as part of that, again, this question of what's the dimensionality of safety for systems that have AI that's embedded. And I just want to mention in this regard an important paper that just came out, I mean, less than a week ago, that are concrete problems in AI safety. And we have in the session today, at the end, Dario Amodei, who's one of the authors of that paper. That's a pretty interesting attempt to try to present some organized thinking in this regard. What might it mean from an engineering perspective, to change gears, for us to think about designing in safety, considering safety from the very outset? And then finally, what might be some measures that we could identify? Because if you want to create incentives for people to do things, then you have to have some observables that can drive that. So the three sessions that follow then kind of triangulate in on the safety challenges from different perspectives. The second session focuses on approaches that involve kind of intrinsic features of the AI itself, adaptation of the AI capability. And questions come up here, for example, how can we pierce the opacity of these modern statistically based systems? If you went to Google I/O some weeks ago, the question to be asked is, when you look at the image of the dog, how the heck does it know that it's a Pomeranian? Right? That's the question you want to ask. You want to get that explanation. Other questions are, how can we develop better objective functions to assess what we've learned? How do we manage the learning process? Maybe that's a way to influence this, selection of data. An important issue, or whole set of issues, has to do with the old idea of frame problems. All of these various pitfalls. How much of the actual operational reality is embraced through our abstractions in our models? Because we know, for example, from cybersecurity, that a good adversary will actually try to figure out how to bypass whatever edifice of abstractions we conjure up. That's how you win, right? You have perfect crypto algorithms, but if you use electrical interventions, those algorithms may mean nothing at all. And when we think about, for example, autonomous vehicles and systems like that, have we modeled correctly construction zone, architecture, weather, and various other characteristics. Okay, the third session involves approaches related to mathematical models and reasoning. How do we model the various kinds of safety properties that we might identify? Can we reason within those models? And with respect to the frame issue, what are we not modeling? Okay, and this area, of course, as you know, and this is kind of partly why I'm interested in this, this has its roots in symbolic AI, the early symbolic AI. I was at the Stanford AI Lab in the 1970s. I was at the Edinburgh Department of AI, right? And then AI went into statistics, and I stayed with software. But anyway, that brings me to the last session, in fact, which focuses on systems and software engineering. So these are the three kind of perspectives that we're using to triangulate on this. And questions here would be, so what are some useful architectural and design concepts? What architectural features could we identify? I see David Garland here. So I have to say this, what architectural features could we identify that might help us, in fact, bound the consequences of AI accidents? How can we mitigate the framing problem without modeling the entire world? What about there's some important ideas, and I need to show you this. Bear with me. I mean, there's some architectural concepts that people have conjured that involve certain features which the big red button, for example, right? So this is actually an architectural concept that safety engineers think about, and there are other ideas as well. So since I mentioned David Garland, I have to thank him for this. This is in his office, and it's connected to his computer. Who needs, all these, anyway. Okay, so, but we also want to build on practices for safety, systems engineering, and safety engineering. And the people who are actually building robots and autonomous vehicles, they're doing all this, but they also know, very importantly, they know the limits of their practices. And so, and frankly, except in limited domains, flight controls, for example, we aren't really very, and certain kinds of cryptography, we're not really very good at this. So the question is, how can we improve? So really, we need all three of these perspectives, and we know that there is no single kind of magical technical innovation that is going to crack it for us. We also want to try to understand these engineering trade-offs. Let's not take anything for granted. Okay, so that's tomorrow. Today, and this is the transpose kind of tomorrow, we have this three-part agenda. So in the first part, we're setting context. And unfortunately, Jason Schultz, who has been my kind of partner in crime, so to speak, working with Ed at OSTP, he's not able to be here today. We're hoping he'll show up tomorrow. So in the first part, we're going to set some context. And the centerpiece for this is a talk by Eric Horvitz, who's sitting right here. And he's been thinking about these issues for a long time in the context of both applications and also in technology. In the second session, there's Andrew Moore, just walked in, who will lead off that session. We're going to hear from people who are thinking about what are the technical concepts, but how do we do that in the context of applications? And in particular, how do we think about safety issues in particular contexts of use? And I'll introduce those speakers after the break. And then in the third session, we're going to do just a few deep dives to explore some particular technical ideas. So I want to say, with respect to these meetings, we are taking a pragmatic approach. But I also think it's important for us to acknowledge that in the bigger world, we're not only deploying these systems, but there are all these people out there, and a lot of these people are experiencing some fears. And so I think it's important to acknowledge some of these fears and to recognize that they go way, way back. And in fact, the examples I've selected here are all at least half a century old. Okay, RUR, Karl Čapek, the play, Asimov's laws. Does anybody know Asimov's fourth law? There are only three, but you know that autonomous robot that was trying to navigate its way down the East Coast? We're here in Pittsburgh. Got to remember this. Don't avoid Philadelphia. That's the fourth law. I won't mention W.C. Fields. And this Magnus Robot Fighter comic book, this goes back to the early 60s. It's a whole series. And you can see how dramatic it all is. But in fact, the golem here goes back to the 16th century. So there's quite a bit of conjuring about this whole thing. I love this stuff. But in fact, we're in the business of building real systems that do real cognitive things, and we have to pay attention to how we engineer those systems. We have to pay attention to the operational context in which we deploy those systems. But we also have to pay a little bit of attention to how all this is going to be perceived. And I think for us, we have an opportunity. We actually have kind of a window of opportunity. And I'm going to try to infect you with some optimism now, okay? Because I really believe this, that we have a window of opportunity to kind of introduce a safety-first approach to our engineering thinking about constructing AI systems. And I think we're in that window right now. It's not going to last forever. I have a feeling that Ed and his colleagues perceive that as well. So let me offer an analogy. And the analogy is AI safety with cybersecurity. Okay, and so there are important similarities. They're both highly dimensional, right? When you talk about cybersecurity, there are all these various flavors of confidentiality, integrity, authorization, identity, all these various things. Same with safety. Both have to consider algorithms and abstractions and engineering practices. Both have to think about faults, errors, failures, hazards, adversaries. Both have inadequate models, right? People trying to break your frame principle, and the models don't encompass the entirety of all the worldly features, right? So, so this, well, all right, fine. This does not sound like optimism, and I just told you I was offering you optimism, but there are important differences. And that's what I want to get to, that favor what we're doing, okay? And one of those is that with AI, we're still in the very early stages of development. There's kind of a plasticity still in how we actually build systems. We're not stuck yet with bad norms for our development practices, our evaluation practices. For example, so much after the fact, reverse engineering goes on with cybersecurity. We have business norms that create incentives that go in the wrong way for a lot of things, safe harbors and the like. We don't have that yet. So let's seize the opportunity and really be aggressive about this to try to think about, how can we engineer AI-intensive systems that have safety built in? So the program is one afternoon. We're going to end at about 5:15 or 5:30. So we can't be comprehensive, but at least we can start an interesting conversation. And I'd really like to thank you all for being here today. And now I'm going to introduce Eric Horvitz from Microsoft, who is going to give our kickoff speech. And here we go.